Today we will start chapter 9, that is from optics, ray optics. So in ray optics the first topic is refraction. In class 10 you got the concept of refraction, that light, it bends from its original path when it travels from one medium to another, and that is called refraction. Say for example, if I say that this is the boundary between two medium, this is suppose medium 1, this is suppose medium 2, and this is the normal. Okay, so when light travels like this is the incident light, this is moving from medium 1 to medium 2. So as it goes, as it enters in medium 2, this is the expected direction of light, it was coming in this direction, but in this case light will not move in this direction, but it will bend from its original direction. It may bend towards the normal like this. Towards the normal means this one is normal, okay, this dotted line is normal. So if it bends towards the normal like this, we have to understand that medium 2 is a denser medium than medium 1, okay. But if it goes away from the normal means if it goes like this, if it bends in this direction, then we have to understand that medium 2 is a rarer medium, okay. So in this way refraction takes place. So how we define refraction, as I already told you, that you have to write that when light moves from one medium to another medium, it changes its path, and this process is called refraction. So in refraction we have two laws. The first law is that the incident light, the normal, and the refracted light, this is called refracted light, this one, okay. So incident light, normal, and this is called point of incidence. So first law is that incident light, normal, and the refracted light, all the three lie on a same plane. That is postulate, number 1, that is the law of refraction, first law, number 1 law, okay. Law number 2, for law number 2 we need two angles. This is called angle of incidence, we write it by I. This is called angle of refraction, we write it by R. So according to law number 2, sine of I divided by sine of R, that is a constant, and this constant is called refractive index, we write it by mu, or in some book you may get it as n also, same thing, mu or n, okay. Sine of, and this law is also called Snell's law, Snell's law, Snell's law, okay. This law number 2 is called Snell's law. Now what is this refractive index, mu? So remember that whenever we are writing mu here, one thing you have to understand, that this is the refractive index of the second medium, medium 2, with respect to medium 1, okay. So this mu is the refractive index of medium 2 with respect to 1. So that is why sometimes we write it like this also, mu 2 1. 2 1 means it is the refractive index of 2 with respect to 1. Suppose, okay, suppose there are two medium, this is the boundary, this is medium 1, okay, this is medium 2, this much, medium 2. Suppose it is a glass slab, this is medium 2, and again this is medium 1. Suppose it is air, medium 1 is air, medium 2 is a glass slab. So when light travels from medium 1 to medium 2, how we will show it? First of all we have to draw one normal, okay. Then incident light, alright, incident light. Then we have the refracted light, alright, refracted light, fine. Angle of incidence I, angle of refraction R. Here again another refraction will take place at this point, okay. At this point another refraction will take place, because now the light ray is moving from medium 2 to medium 1, and suppose this is the, okay, just a second, suppose this is the second refraction, this one, second refracted ray. Okay, this refracted ray second time when it comes out, we also call it emergent ray, and this is also called angle of emergence, E. Okay, now here two refractions are taking place. Now if this angle is R, definitely this angle is also R. Alright, from the geometry it is clear. So if you want to write Snell's law for two refraction, for refraction 1 which is taking place here, refraction 2 is taking place here, if you write Snell's law, for the first case I will write sine of I, okay, I by sine of R mu, what it should be, 2 1. This is the refractive index of medium 2 with respect to 1. Similarly, for the second refraction which is taking place here, what is the angle of incidence? Angle of incidence in this case is, angle of incidence is how much? It is R in this case, because for the second refraction this is the incident ray. Alright, so if we write Snell's law for the second case, this will be sine of R, because R itself is the angle of incidence. Angle of refraction in this case is E, which is the angle of emergence. So sine R by sine E. In this case, what is mu? Mu is 2 1 I have written here, but it will be mu 1 2 for the next case, because when light is moving from medium 2 to medium 1, right? 2 to medium 1 means which one is the second medium actually in this case? Second medium is medium 1, right? So 1 with respect to 2. One thing you remember, that mu 2 1 and mu 1 2, how they are related? They are reciprocal of one another. Reciprocal of one another means, if I make it reverse, means if I write sine E by sine E by sine R, then this mu will be mu 2 1, reciprocal. Okay, now this equation and this equation are same. Right hand side is same, mu 2 1, so left hand side should also be same. That means sine I by sine R, that should be equal to what? Sine E by sine R. If it is so, from this two it is clear that I is equal to what? E. That means angle of incidence and angle of emergence are same. Okay, so this proof you can do to show that angle of incidence and angle of emergence both are same. So I hope it is clear. If you have any doubt, you can tell me about it. Okay, alright, so this is one part of refraction. Then we will discuss about this refractive index, about mu. Okay, suppose this is the boundary of a medium. This medium is air medium. This medium is some medium like glass. Okay, suppose it is glass. Now refraction is taking place. This is the normal, incident ray, refracted ray. Okay, so in this case, mu, if I write mu, I'll write GA. GA means this is the refractive index of glass, because here glass is the second medium. A for air. Okay, so 2 1, instead of writing 2 1, I have written GA. So this mu GA is nothing but actually it is a ratio between C and V. What is C? It is the velocity of light in the first medium, means in air, that is C, divided by velocity of light in the second medium, which is glass. This is V. V means it is the velocity in glass medium. So this ratio C by V is the refractive index of the second medium. Okay, suppose instead of glass, if the second medium is water, then this V will represent the velocity of light in water. Remember that out of these two medium, when one medium is air, then this refractive index is called absolute refractive index. Absolute refractive index means one medium will be air. Generally, basically the first medium is air and the second medium can be anything, glass, water, whatever it is. But the first medium, if it is air, then this refractive index is called absolute refractive index. Okay, so if I ask you what is the definition of absolute refractive index, it is the ratio between velocity of light in air to the velocity of light in a particular medium. Okay, now this refractive index, we have another type that is called the relative refractive index. In relative refractive index we have two medium but other than air. Suppose it is glass, the first medium itself is glass, the second medium is water. Suppose this is the normal. Okay, and this is the incident light, reflected light. Alright, so in this case when you write mu, what it should be? W G, no A, means no A means no air. This is the refractive index of water with respect to glass, so that will be, there will be no C. In earlier case it is C by V. C means velocity of light in air specifically, but air is not here, so what we will write? V1 by V2. What is the meaning of V1? V1 is the velocity of light in the first medium. First medium means in glass, here V1, and V2 means velocity of light in the second medium, that is in water. This is V2. So this ratio will be the refractive index, and the name of this refractive index is relative refractive index, when one medium is other than, or when both the mediums are other than air. If it is air if it is one medium is air, then that is absolute refractive index. When both the mediums are other than air, it is relative refractive index. So I think it is clear, this thing. Another very important thing that you have to remember, I told you about this, like mu 2 1 means what? Refractive index of medium 2 with respect to 1 is always equal to reciprocal of mu 1 2. Okay, right? So this is the thing that you have to remember. This means it is the refractive index of medium 1 with respect to 2. This is the refractive index of medium 2 with respect to 1. So how they are related? They are reciprocal of one another. Alright, so this much is done. So for this video, this much only. Then in next video we will discuss about total internal reflection. Thank you.